So this is the read aloud for chapter 13, lesson 3, changes in climate. We're not going to read this page. You can read Planet Diary on your own. How do scientists study ancient climates? Think about a weather forecast that you've seen or heard. This forecast is a prediction about changes in upcoming weather. This prediction can help you plan your day. However, long-term changes in climate happen more slowly and may not be apparent for years, so you don't see them for years. Yet, regardless of how slowly climate changes, the consequences can be great. That is question 10 on your test. Take Greenland, for example. Today, this large island is mostly covered by an ice cap, but 80 million years ago, Greenland had a warm, moist climate, so it was wet and warm. Fossils of magnolias and palm trees found in Greenland provided evidence for this climate change. So now that it's freezing, they don't have these things available. Today, these magnolias and palm trees are native to warm, moist climates, like Florida. Scientists assume that the ancestors of these trees required similar conditions. This next sentence, this key fact, is question number 9 on your quiz. In studying ancient climates, scientists follow an important principle. If plants or animals today need certain conditions to live, then similar plants and animals in the past also require those conditions. Actually, it might be question 8, but it's one of them. So they use this key fact in their true and false. We're going to talk about pollen, tree rings, and ice cores. One source of information about ancient climates is pollen records. Each type of plant has a particular type of pollen. Some lake bottoms have accumulated thick layers of mud and plant material, including pollen. So we study the pollen at the bottom of lakes over thousands of years. Scientists drill down into these layers and bring up samples of pollen to examine. I'm repeating because it's one of the questions. Using a microscope to look at the pollen in each layer, scientists can tell what types of plants lived there. Tree rings. Tree rings also tell a story about ancient climates. Each summer, a tree grows a new layer of wood under its bark. These layers form rings. Wide rings indicate a good growing season. It was nice and strong. That was long or wet. Narrow rings indicate dry year or short growing season. They're thicker and wider because they have all the nutrients and the things that they need to get strong and healthy. From these data, they can see if previous years are wet or dry, warm or cool. Ice cores. Imagine drilling 3 kilometers down into ice and removing an ice core almost 8 times longer than the Empire State Building. Ice cores have a layer for each year, just like tree rings. Scientists study these layers to find out about Earth's climate record. They can also analyze what in the layers of ice, such as pollen and dust. Page 489. Natural factors can cause climate change. Here's one of our answers. It's just worded different. Why do climates change? Possible explanations for major climate changes include movement of the continents, variations in the position of Earth relative to the sun, major volcanic eruptions, and changes in sun's energy output. So major changes in volcanic eruptions are major changes in climate change. Movements of the continents. This is another answer on the quiz. The continents have not always been located where they are now. In figure 3, about 200 million years ago, there was Pangea. At that time, most continents were far from their present positions. Continents that are now in the polar zones were once at the equator. This movement explains how tropic plants, like the magnolias and the palm trees, have lived because they were in a warmer area. Now they're at the top, like Greenland. The movements of the continents over time changed the location of the lands. These changes affected the global patterns of wind and ocean currents, which slowly changed climates. As the continents continue to move, their climates also began to change. Movements of climates is important to know. Earth's position and the ice ages. So it says the angle of Earth's axis and the shape of Earth's orbit affect Earth's climate. That's important. Earth travels at the elliptical orbit around the sun, but the shape of the orbit The ellipses varies over a period of 100,000 years. When Earth's orbit is more elliptical, less sunlight reaches the Earth. We need that sun to keep us warm and give our things energy to grow. The change causes Earth to experience an ice age, a period of glacial advance. Earth warms when its orbit is more circular. The angle at which Earth's axis tilts and the direction of the axis changes over time as well. These changes in Earth's position affects the severity of ice ages. Altogether, these changes cause repeating 100-year cycles of ice ages interrupted by warm periods. The ice ages, just to refresh, the change causes Earth to experience ice ages. During ice age, huge sheets of ice called continental glaciers. This is one of our answers. During ice age, huge sheets of ice called continental glaciers covered large parts of Earth's surface. Glaciers transformed the landscape. They carved grooves in solid rock and deposited piles of sediment. They also moved huge boulders hundreds of kilometers. From this evidence, scientists have concluded that there were about 20 major ice ages in the last 2 million years. 20 major ice ages. This is one of the questions also. Brief warm periods called interglacials occurred between long, cold ice ages. The last ice ages ended about 10,000 years ago. And we will talk about volcanic activity and solar energy, and that will be the end. Volcanic activity. More volcanic eruptions release huge quantities of ash and aerosols into the environment. Aerosols are solid particles of liquid drops of gas. Aerosols and ash can stay in the upper atmosphere for months and years. That's why they say don't use aerosol cans. Scientists think that aerosols and ash reflect away some of the incoming solar radiation and may lower temperatures. For example, the eruption of Mount Tambora in Indonesia in 1815 blasted about 100 cubic kilometers of ash into the atmosphere. And now it's dramatically colder. Climates worldwide were dramatically colder the next few years. So it had this big blast, and now these people are freezing. Solar energy, short-term changes in climate have been linked to changes in the amount of light given off by the sun. The amount of changes over a regular 11-year cycle can also change over hundreds of years. The Little Ice Age was a period of cooling between the 1600 and 1850. It was caused by a decrease in the sun's energy. The number of sunspots, dark, cooler regions on the surface of the sun, increased when the sun gives off more light. They can be used to measure solar output over the past 400 years.